Hello, Algebra 1. We're back in Unit 4, Lesson 2 on function operations. Our goals for learning for this lesson, 4.2, the first is to evaluate the output or range value of a function, giving an input or domain value, perform operations with functions, find domain and range values on a graph, determine the independent and dependent variables in a real-world example. So let's get started. All right, we've got a rather short vocabulary list, and these terms should look familiar from the last lesson, but let me give you a moment to read them. All right, so our directions say that functions can be added, subtracted, multiplied and divided to create new functions, but we're also going to look at what it means to evaluate a function. So sometimes we're going to be given a value to substitute into our function to see what we get. So you can see I've got 4 functions right here. I have a function named function g of x equals 3x plus 1. I've got function f here. I have function h. And I have function j. Okay. So what it means to evaluate a function is whenever I have g of 10, it means this is the x value. So I'm going to find function g, which is the first one, and I'm going to replace any x's with a 10. It's really that simple. So I've got 30, 3 times 10 is 30 plus 1. That would be 31. That's what it means to evaluate a function. Our next one here, f of 3. It means find function f, which is the second function, and replace any x's with 3. So we can see we have x squared, so I'm going to have 3 squared. So right here it's this function, plus 7. So that's going to be 9 plus 7, so my answer is 16. Okay. And then the last one, h. So h is 12. I'm going to change my color here. It's a new problem. There we go. H is 12. The x is in the denominator, so we've got 12 over negative 2. So this is negative 6. So let's talk about what that means in terms of a function and in terms of ordered pairs. So on this first one, g, I said that our value was x. That means our output is y. Our 10 is our domain value. Our 31 is our range value. In b, the 3 is our domain or our x. The 16 would be our y or our range. So when we start to get into graphing, we've got an ordered pair. Our third example, x is negative 2, y would be negative 6. Our domain value is negative 2, our range value is negative 6. So that's what we're looking for in these first 3 examples. Example D, okay, this one's a little different. I'm not giving you numbers. I'm telling you to add function j plus function g. So lots of notation to get used to here. So function j is the 4th one there. It's 2x plus 9. And then we're going to add, because there's a plus in between, to the g function, function g, which is 3x plus 1. And so we're going to combine any like terms. So 3x plus 2x or 2x plus 3x is 5x. I'm going to write it down here, 5x, and then my constant times my constant is plus 10. So you can actually combine or do operations with functions themselves. It's really just simplifying expressions. So for example, e, we've got 5 times g, function g, which is 3x plus 1. That's all it's telling you to do there is add them. So we're going to distribute that 5, and I get 15 x plus 5. So that one we multiplied a constant to our function. And our last example, we're going to subtract an 8. We're going to subtract an 8 from function f. So we've got x squared plus 7 minus 8, which would give us x squared minus 1. All right, I'm going to pause there and see if you have any questions so far before we jump into our final example for this video. Okay, so we're going to look at this a little backwards. So remember what I've been telling you is if we're looking for x and this is the output, so 16 is the output. So 16 is the y value, the output value. This one's a little bit backwards, so we want to find what x would be. You take your function 3x plus 1, and I set it equal to 16. And we're going to solve for x here. We're going to subtract the 1, so I get 3x equals 15, and then divide by 3, and I get x equals 5. So this is backwards. I'm giving you the output or the range value, and I want you to give me the x, the input, the domain value. Definitely thinking about this in reverse. Let's take a look at example H. H is 12 over x. We want that to equal -2. I don't want you to put the -2 into it. Okay, so there is a little trick. Hopefully you guys remember we can swap these two values. I've shown you this before with fractions. We can change this to 12 over -2. It's really just cross multiplying equals x. So 12 divided by -2, x is going to equal -6. All right. Okay, so that wraps up this video. Let me know if you have any final questions. I actually have one for you just to make sure you're understanding what we're doing.